Welcome back. We are talking about cognition and language in this section of the class. And these are somewhat related, somewhat distinct concepts. Cognition, of course, is how we think and process information. And language is similar, but with, of course, written, auditory sort of signals that represent language. One of the most interesting things about this is the sort of breakdowns that happen cognitively, how we can be fooled, like when we talk about sensation and perception, the visual sort of tricks that we could see. But here it's also, different cognitive manipulations that happen that make us respond in interesting ways. Like the Kahneman and Tversky example I'll give later. Kahneman and Tversky are just two researchers that looked a lot at how we frame decisions, and the framing of that decision can impact how we respond to that decision-making task. Of course, language is also fascinating, and the videos of the bonobos doing sign language is really interesting in terms of what they can and can't learn and use language for. So I encourage you to look up those videos of the chimpanzees and apes learning sign language. I'm not sure which type of ape it is. I think bonobos are chimpanzees, I want to say, are related to chimpanzees in the great ape family. Anyways, very close to us, like 99% similar genetically, so language is very strong there. Anyways, cognition in general is the thinking and using of knowledge, right? So the processing that we do. This is an active sort of process that takes place where we focus our attention on something. So a lot of what we're talking about is related to attention and controlling that attention. But the point of that is to categorize information and to fit it into our schemas that we have of the world. We talked earlier about how when things don't fit, we have to accommodate versus assimilate. This is similar sort of concepts here. In the case of attention, though, it's more about where we focus our attention. Bottom up being that sort of response, sensory sort of response to a stimulus, and top down being where we're deliberately focusing our attention, such as the example below. If you stare with your eyes on the X in the middle of that bubble of letters, you can sort of still read the letters in the peripheral, like NWFK, even though you're sort of forcing yourself to pay attention to it. Not like a light blinking where you see it happening whether you want to pay attention or not, or the fire alarm maybe in your building. It's not an effortful sort of top-down process there. You know what's going on based on those sensory stimuli. Anyways, attention is limited, of course, based on genetics and personality, but of course on other sort of instantaneous things like the neurons and the synapses themselves being competing with each other, sort of trying to perform the same tasks, so that interference can be an issue. And of course, the way that we direct our attention, that effortful sort of, bottom-up processing and top-down processing, the top-down being the directed attention, that if you let your mind wander, those sorts of things, that wandering may also produce lack of attention towards certain stimuli that you may want to be focused on. This can also be represented in what's called change blindness. Change blindness can be illustrated very aptly by the videos of, let's say, a gorilla walking through a video of ballerinas and you don't notice the gorilla. There's some great ones of that called selected attention or directed attention manipulations. If you search YouTube, those should pop up. Very interesting stuff. You can show them to friends and show that they don't notice differences between scenes or images based on that sort of thing. The Stroop effect is an interesting phenomenon that's showing that competing sort of mechanism going on. In this case, the Stroop effect is illustrating the primacy of language in our lives and how strong language is. If you have a list of words and those words are color-coded, we tend to read the word rather than list the color. So in the next screen, try to say the colors of the words rather than the names of the words. If you try to say the color that each word is written in, it's very difficult. So try that for a second on your own. Obviously, you want to say red, green, blue, yellow, pink, like that. But when it becomes disjointed, you will see that it's much more difficult. Google those examples too. In terms of attention, we have some personality or trait differences that manifest. Some people call that attention deficit disorder. The newer name is attention deficit and hyperactivity disorder, the ADHD. The earlier one was really just marked by distraction, a little bit of impulsivity, where now it's also about the hyperactive sort of component to it, the fidgetiness or the lack of ability to maintain attention towards a certain task. So they test these sorts of things by looking at, choice delay, stop signal, manipulating the ability to maintain attention on something. So they look at people with ADHD and how they perform on these different tasks, and they show that people with more impulsivity, more ADHD, tend to be less able to delay choices and more apt to pick a earlier choice than later. Why is this important? Well, like I said, there's attention and then there's categorization, right? So when you're categorizing or accommodating or assimilating, all of those sorts of things, we're putting things into categories that make more sense for ourselves, right? So sometimes this can be advantageous, sometimes this can be disadvantageous, depending on the circumstance, right? If things don't fit our schemas, or what we call prototypes sometimes, that example, then it's harder to accommodate or assimilate that information. So that can be very difficult. With words, of course, this is related to our neurons, so that spreading activation that connects those sorts of things is very important. And words can be primed. We say primed in that a similar word or a similar concept can prime the availability or the activation, if you will, of those other memories or cognitions. So if someone shows you a picture of a house and then asks you to pick the correctly spelled word out of a list of words, and they're all related to house, like door or driveway, you're much more able to perform that task. And they do this by timing you. So it's all about response time with those certain tasks. Anyways, when you get a little bit more complicated with sort of problem solving, what we do when we cognitively evaluate these things is we try to understand the problem itself, right? So that's called the problem formation or the initial formulation of the problem, right? So what we're doing there is we're considering the choices when we're doing the maximizing, all those available choices to find the best one. Satisficing, they call when we sort of settle early and search until we find a good solution. So those are sort of the analogies to quick and dirty decision making, or slow, effortful processing in terms of maximizing. We can manipulate this and look at this by giving people problems to solve and see how they decipher these problems and come up with solutions. One of the classics is displayed there for you, the matchbox, which you don't see very often anyways, and then candles also replaced by LED lights now, but regardless, they're trying to ask you to create a candle holder on the wall, given these tacks, matchbox, and candles. And what we do is we come up with solutions, right? We formulate that solution. If we're able to flexibly interpret our world and flexibly interpret the use of products, then we may be able to come up with some solution. That mental set is the set of ideas, set of sort of attributes we give things and the possible uses for them. So a lot of times when people are given these tools, they may or may not be able to produce a candle holder if they can't flexibly interpret the uses of these different aspects. So of course, as the image shows here, this would be the optimal candlestick holder, right? But that's not always the case. We use different strategies to come up with these solutions, these algorithms and heuristics, as they're called. So algorithms, of course, are those sort of basic sort of devices that we use to solve problems, right? Effortful solutions. Heuristics are a little bit more low-cost, sort of base strategies that maybe we've had before, right? The two mentioned in the book are the representativeness and availability heuristics. Representative being, that it looks like the others. So if something looks like a duck, you call it a duck. Availability would be the the other instances or examples of this that you have, if you can easily think of the example and you have a lot of those examples in your mind, then that thing fits into your schema easier, right? So if something looks like what it's supposed to, or if it's common or more easily primed in your mind, that availability makes that solution or makes that alternative much more likely. Of course, this leads to errors, right? One thing that happens a lot in science that we talk about is the confirmation bias. So in human cognition, when you do the confirmation bias, that's when you're looking for evidence that confirms what you already think, or what we say is your hypothesis, right? Instead of falsifiable evidence. When we talk about research methods, we talk about good hypothesis being falsifiable. If the confirmation bias is strong, then you're likely to look for not rejecting information, but positive, confirming information. This is true, let's say if you really like somebody or dislike them, you may look for information that confirms that worldview, that they're a good or a bad person, right? Anyways, framing, sunk cost, these are all sort of further examples of this sort of errors that happen. Framing being that we will respond differently based on the cues. When we get to Kahneman and Tversky, they're really looking at framing effects on decision making. In their case, how many people will live or die with a certain medication is a good way of seeing sort of people's loss aversion or their tendency to want to avoid loss. So if you say you'll save 90% of the people with a drug, or if you say you'll kill 10% of the people with a drug, people will decide to use that drug at different rates, right? Sunk cost is something that you also may see in your everyday life, such as if you're driving to the store and you get halfway there, but you remember you don't really even need to go to the store. You may still go to the store because you have some sunk cost into the sort of process, right? So you're doing something because you've already spent something or moved in that direction. We also call that escalation of commitment in social psychology. So your commitment is escalated the further you get towards that end goal. Going back to Kahneman and Tversky for a second, they came up with the System 1 and System 2 thinking as well. So the heuristics fall into System 1, which is quick automatic processes, looking for easy solutions to questions that may be simple. So simplifying, using a strategy that simplifies or comes to a quick decision, whereas System 2 thinking is much more calculating, right? These are those algorithms that help you sort of test a hypothesis, and this is sort of calculating and using the information you gather. So this is a little bit more effortful. Well, where does this come into play? It comes into play with decision making, right? So they look a lot at emotional factors and these framing effects that you can do based on, your loss aversion, as they say, or sometimes they say diminishing returns, or in this example down below, the diminishing sensitivity. Like I said, the classic example is when they say they're rolling out a new drug, and the participants read about this new drug for, let's say, a third world country, and saying that giving this drug will kill 10% of the population may lead people to not want to use that drug as much. However, if you say you're going to save 90% of the people, that puts you in sort of a domain of gain versus the domain of loss, which is a very similar concept here. So emotions framing can really change the way we see these outcomes and make these decisions. Moving on to language. Language is one of those core things that whether it's given to someone or not, they'll sort of invent their own language, as we see with people who are devoid of language. And we see that most animals have some way of communicating, whether it's through pheromones and chemical signals, or even your cat. Even though you cannot talk to your cat, if you blink at your cat, that is a communication to that cat of safety. Anyways, we produce this, so they say human language has the power of productivity. That's a big issue when it comes to other animals, because they may be able to replicate or use symbols, but that production and combination of words to express ideas is what really sets us apart from some other animals. So the complexity of that language, putting the pieces together. To understand language, you must first understand that language is not intelligence. You can be very smart or not very smart and have language and use language equally. Of course, very smart people may use fancier language, but it does not necessarily produce language. Everybody will have some sort of language. Even ants that may not necessarily be very smart have very sophisticated languages. Anyways, as we said with the framing, context really helps us interpret the sorts of language stimuli that we perceive. So words, sounds can all be very context dependent. And even within words themselves, there's this superiority effect that we see, that we tend to identify a letter more accurately when it's a part of a word than it's presented in and of itself. So that sort of building block of the letter when it gets to the word level is more meaningful to us. And a lot of the priming studies use the words that are associated with each other, like house, door, driveway. They don't necessarily use letters or numbers. That's a little bit too low in terms of the building blocks. When we have problems with language, usually it's something related to an aphasia. That's a language impairment of some sort. So we call it a Broca's aphasia when it happens in the Broca's area. The Wernicke's aphasia is basically an area of the brain associated with the inability to recall nouns, specific sort of language, meaning, where the Broca's aphasia is more about production. So they may sound odd, where the Wernicke's they may not remember things. So totally different areas of the brain that can be damaged or potentially malformed through, let's say, premature birth, oxygen deprivation, that sort of thing. And of course, we study people with damages to these areas to see what those impairments are. That can be very interesting research, although unfortunate for the people. Bonobos are another type of person, if you want to call them people we study. As you see the little image there, they sometimes are very people-like. They use a lot of sophisticated language, and of course they use tools, right? They are very social as well, so the bonobos are studied in a lot of evolutionary psychology, social psychology, and language. They use a lot of language, and they're a very interesting group of chimpanzees, I believe. Anyways, so it's not related to intelligence, remember. It's distinct, and it's built in, right? So baby monkeys as well as baby humans will try to communicate in some way. And the limits of bonobo language have really taught us a lot about language in general. I encourage you to look at the videos of the little bonobos doing sign language and whatnot for food, and they even learn words like scared and things like that. But it's more the combination that's limiting with them. In humans, we develop from, birth around 3 to 6 months just doing vocalizations and babbling, which is probably about what the bonobos can do, to about 1 to 2 years where we're actually starting to understand words like mom versus dad. And then a little bit later on, we get thousands and thousands of words very quickly. So that's 3 to 4 years, 5, that's great for learning a second language. Once you get to about 11 years old, these centers for language development tend to shut down a little bit, and your ability to learn foreign languages is diminished, which is unfortunate because in the U.S. we tend to start taking second languages in high school, which is past the point of what we call that sensitive period of learning languages. We talked about the critical period in developmental, and this is similar to that. There's a critical period for learning languages, which is right around that 3 to 4 year period. Anyways, one thing that's worth noting is deaf children or children with hearing impairments, if they're not exposed to language, like I mentioned earlier, they will come up with something. There's famous twin speak, so twins can come up with their own secret languages in times, and children can actually learn all sorts of sign language almost from birth, as well as the more vocal stuff once their vocal cords have evolved a little bit. But many people teach children sign language very early on for things like milk or hungry, and they can do those signs pretty easily. It's interesting that they also tend to correlate these skills between reading sign language, meaning that it's all affected by the same parts of the brain. It's all related in terms of the abilities are coming from the same areas. like those Broca's and Wernicke's areas. Anyways, these sensitive periods can also impair future development. So if children aren't given any language at all or set aside, which some of these sort of horrific examples of child maltreatment can show you when a child is sort of deprived of any social interaction. There's examples of children locked in attics and stuff. Later language development is actually very difficult. They also show there's some difficulties associated with bilingualism, but even though sometimes it's confusing or it takes a little bit longer to master them, it does have later benefits like creativity, decision making. You can actually see cognitive benefits from learning multiple languages, which is interesting. So creativity and things like that, but also just perspective taking abilities are usually higher in people that have multiple languages. Anyways, hope this was interesting, and see you next time.